When I add variables into the denominator, it doesn't drastically change my process. I do need to indicate non-permissible values now with my solution, just like what we did with the previous ones where we were simplifying, but I can think of x as, or a, or whatever it happens to be, as just another term that exists in terms of my common denominator. So if all my denominators are x, they're already over a common denominator, just x. So I can say that this is the same as 2 plus 7 minus 1 all over x, or 8 over x. But I still need to indicate that because I have an x in the denominator by itself, x cannot equal 0. I need to make sure that I state that non-permissible value. When I get to example B, then I have 2a and 2a. Once again, same denominator. So I can say that I'm going to take all of this. 5a plus 3 is getting added to a minus 6 all over 2a. And because I didn't need to multiply them by anything, I can just combine my numerators because they're getting added together. So I can say that if I have 5a and a, I have 6a's, and 3 and negative 6 is going to give me negative 3 all over 2a, and in this case, a cannot equal 0. When I get to example C, still same denominators, but in this case, they are binomials, which is fine. I'm still going to say that it's all going to be over the common denominator of 3y minus 1. There's a subtraction between the terms, so I'm going to say that's going to be 3y minus 1 in the top. And because I have a binomial in the top, I would see, can I simplify it at all? No, they're the same in the numerator and the denominator. 3y minus 1 over 3y minus 1 divides out evenly, and my answer is just 1. But I still need to account for the fact that y, based on the factor in the bottom, cannot equal 1 over 3. So I still need to make sure I incorporate what the non-permissibles are by stating that the denominator can't equal 0. And finally with the last one, same idea, binomial on the bottom, same common denominator. I'm going to watch out for that negative that exists in here. And I'm going to say that this is going to be equivalent to 4x plus 10 minus 2x plus 4 over x plus 3. And I got to be careful because this negative is going to apply to both terms. That's the most common mistake that's made with these ones. This means that what I have is 4x plus 10 minus 2x and minus 4 over x plus 3. This is going to give me 2x plus 6 over x plus 3. And when I take a look at the numerator, I can factor that down. It has a common factor of 2. I need to show it factored down to see if there is a common factor, and lo and behold, there is. It is a common factor of x plus 3. Which means that it's just going to equal 2, but I still need to state the restriction that x cannot equal, what was our denominator, or our LCD. I can pull the non-permissibles from the LCD and say that this is true as long as x does not equal -3. Now these ones worked out nicely because they all had the same common denominator to begin with, but frequently you're not going to have a common denominator to begin with. So we need to find what they are. So when I'm looking for a common denominator, I'm going to look at the coefficients and I'm going to look at the variables. If the variables are the same, I don't need to change anything with the variable. I'm just going to change the coefficients. So between 3 and 7, the lowest common denominator is going to be 21. So I need to multiply the first one by 7 and the second one by 3. This is going to give me 7 times 5 is 35, plus 3 times 2 is 6, all over 21p. Or 41 over 21p. And for my restriction, p cannot equal 0. For the second example, I look at the denominators, and I have 3 and 5, means it's going to be 15, so I got to multiply the first one by 5, and the second one by 3. But I also see that this one has a y, and the second one doesn't have a y, which means that the second one is missing the variable of y. So I got to multiply it by a y as well on the top and the bottom so that they match. This means that what I'm actually going to have is 5 times 1 plus 3y times 6, all over 15, and they both need a y. That's going to be the same as 5 plus 18y, all over 15y. And then I can check and see, can I factor this down at all? No, there's no common factor, which means that's as far as I can go. And this is true so long as y can't equal 0. For example, C. I got binomials, so I'm going to put brackets around them. They both have an x, and between 6 and 3, the lowest common denominator is going to be 6x, which means that I'm just multiplying this one by 1 and this one by 2. And I'm going to watch out for that negative here. So this is equivalent to 1, 2x minus 5, minus 2, 3x minus 2's. And this is all over 6x. I'm going to expand it out, and I'm going to get 2x minus 5 minus 6x plus 4, all over 6x. And when I combine my like terms, I get negative 4x minus 1 all over 6x. And this is true so long as x cannot equal 0. For example, D, between the 2 and the 5, the denominator is going to be 10, which means that I need to multiply the first set by 5 and the second set by 2. But I also see that this one has an a squared and this one only has an a, which means that I need to add in the second fraction the missing a. This is going to give me 5 bracket a plus 7 minus 2a bracket 3 all over that 10a squared that I needed in the denominator. This is the same as 5a plus 35 minus 6a all over 10a squared. Or when I combine my like terms, negative a plus 35 all over 10a squared, so long as a cannot equal 0.